Hello, we're going to talk about topic 5, section 6, which is stationary points. Now, we have talked about this before, but I wanted to do a separate lesson on just it, talking about maximum and minimum points. Okay, there is another type of stationary point called the horizontal point of inflection, so an inflection point, and I'll show you what that looks like later or in a few minutes. So first thing is a local maximum. Hopefully you know that a maximum is going to look like this, where you're going to have kind of like a hill, and that top part of the hill is the maximum point. So we know that the derivative of a maximum is always 0, and it changed sign from positive to negative as you pass through the point. So think about that. The slope of the left side is positive. The slope of the right side is negative. So if it goes positive, then 0, then negative, we have a maximum. If we have a minimum, our graph is going to look like this, with our minimum point being the vertex there. And we know that the slope at that point is 0, and the slope of the left side is negative, and the slope of the right side is positive. So that indicates a minimum. An inflection point is just the same thing. Again, it's always, the derivative is still 0, but now it doesn't change sign. So we're going to have a positive, 0, and then a positive. So the left side is going up, and the right side's going up. The left side's going down, slope of 0, right side going down. I'll show you what that looks like again in a little bit. So let's do some problems. Start with this curve. Okay, the first thing, find ds over dt, so find the derivative. So the derivative is going to be 9t squared plus 4t minus 4. And then on the same axis, we're going to sketch the original one and its derivative. So I've already done that. It's right here. Oh, let me fix the colors. Okay, so here I have graphed the two equations. Okay, I've got the green one is the original and the purple is the derivative. So here we want to find the equation where the derivative equals 0. So that's when we have 0 equals 9t squared plus 4t minus 4. Again, there you can solve quadratic formula, factoring, completing the square, or just using your calculator and using that Poly simulation app. Okay, so doing that, I'm going to find what t equals, and I should get 2 t values. Okay. Okay, so I wrote down the 2 t values that I got using my calculator. And then here we want to state the feature indicated by those points. Okay, so if we look at the original function, so I'm going to do that in green. So if we look at these points, 0.481 is going to be right around there, and negative 0.925 is right there. Those are your minimums and maximums. Okay, so your turning points, these are your stationary points. Okay, so that's a stationary point. You have minimums and maximums. Okay, so if the domain is restricted between -2 and 2, so that means anything to the left of -2 we're throwing out, anything to the right of 2 we're not looking at, which, I mean, that's pretty much our graph anyway right here. But if your graph goes out a little bit more, just know we're ignoring the outside parts. We want to find the actual max and minimum values of these functions. So actually find those values. Well, we just found the x values. So how do we get the y values? We plug them in. So we can literally plug them into our original function, but I don't really feel like doing that. So since we've already got it graphed, I would just trace it and find the point where 0.481 is, what the y value is. Okay, so let me write that out. Okay, so I plugged it into my calculator and I got these points as my y values, and I can identify it as a minimum or maximum by looking at my original graph. Okay, so by just setting the derivative equal to 0, I'm able to find the stationary points. Okay, so in this case, the minimum and maximum. So let's find some more. So here we've got another function. We want to find the derivative. So I'm going to rewrite my equation. Sorry, having a little trouble here. So rewrite it as x plus x to the negative 1, just because that might be easier for some. So our derivative is going to be 1 minus x to the negative 2. So we take a sketch of the curve. So I've done that here. Find the coordinates of any local max or minimum points. So I like to do it when the algebraically. So let's make the derivative equal 0. So 0 equals 1 minus 1 over x squared. So we get 1 over x squared equals 1. So x squared equals 1. So x can either be positive 1 or negative 1, right? We put that square root there, 2 answers. So we want to find the maximum minimum. So let's see, we find the x. So let's find one point and then find the other point. So we plug in 1 into our original equation. So y equals 1 plus 1 over 1. That gets us 2. And we plug in negative 1. Y equals negative 1 plus 1 over negative 1. And we get negative 2. Coincidence, but still, we found our answers. All right, we've got 2 turning points, negative 1 and negative 2, and 1 comma 2. So find the gradient of the 2 points close to on either, but on either side of the minimum point. So let's look at D. So if we look at our like an x-axis, okay, just like a linear, just a your line, just like a number line. Ooh, couldn't spit that out. So here, what we want to do, sorry, I just noticed that was wrong. So then we've got 2 x values we plugged in at 2 and negative 2. Well, at those, my slope, my derivative, was 0. So my derivative, I'm going to put above it. So this is your derivative, so your slope. Maybe that might make it easier. I know we like that. So slope, and this is your x value. Okay, so let's pick a number. What they wanted is close to on either side of the minimum point. Okay. Close to on oh, we actually want to find the minimum, so that's going to be the one over here where x is positive 1. Ooh, why am I putting negative 2? Silly me. Sorry. Where x, these are our 2 x coordinates. So let's just breathe. We've got our x values, negative 1 and 1. We found the y values so we could have the coordinates of the max and min points. Now we want to find the slope next to it. So what's the slope of, let's do negative 2, 0, and 2. So using our derivative function, oh, it wasn't f, it was a y. There we go. Our derivative function, which is 1 minus 1 over x squared. Find the derivative when x is negative 2. Find the derivative when x is 0. And find the derivative when it's 2. I'm picking the numbers around my turning points. So if I plug in negative 2, I get 1 minus 1/4, so I get 3/4. I plug in 0. Well, that's an error. So maybe I shouldn't plug in 0. Okay, maybe I should plug in like 0.5 or negative 0.5. Okay, so I didn't like that one, so I'm just going to pick another one. I don't know why I picked a negative. Ooh, I am all over the place right now. Sorry. And that keeps tapping. Sorry. All right. So let's plug in 0.5. And we get 1 minus, well, 0.5 squared is 1/4. So 1 minus 4, we should get -3. And our slope of 2 is 1 minus 1/4, which is 3/4. So the slope at -2 was positive. The slope at 0.5 was negative. And the slope at 2 was positive. So my slope is positive, then 0. Oh, hold on. This might be easier. My slope was positive, then 0, then negative, then 0, then positive. So this was my graph of my slopes. Positive slope, 0 slope. Negative slope, 0 slope. Positive slope. Well, notice what we have. This shows it's a maximum for this one. This shows, look how it goes down, that's a minimum for 1. So, find the gradient of the 2 points close to on either side of the minimum point. We did that, the slope. So what we would say is the derivative at 0.5 is -3, and the derivative at 2 is positive 3/4, okay, which shows that's a minimum. Okay, so because of this, the left side being negative and the right side being positive, just like we had over here, right? Minimum, negative, and positive. Negative, then positive. Okay? All right, let's do some more. So let's identify and classify the stationary points of this graph. So we need to find all the points. So let's start with finding the derivative. So the derivative of this is 20x to the 4th minus, what is that, 180 x cubed plus 360 x squared plus 80x minus 480. Okay, I really don't feel like trying to do that by hand, so I am going to plug that into my graphing calculator and find my x coordinates. Okay, so using the Poly Simulation app, okay, the Poly Root Finder, that's what I'm going to use. Okay, so putting this into my calculator, I got x can be a couple things. X can be 6, and then I got 2.000000307 or something. So I'm just going to say 2, because we round that to 3 sig figs, we get 2. Ooh, my. Then I get 1.999999693, so that's just going to round to 2. All right, but I don't need to put it twice, right? We've got one x value at 2 already, so then we also have -1. So then we have those are x values, so plug those in to your original equation and get your y value. Okay, so plugging those in, we're going to get these as our points. Okay, so then we just plug them in. Okay, to get those. So let's see, we've got these 3 points. We have -1 up here, then we have at 2 here, and 6 way down here. Okay, we want to classify them. Now here we can visually see how it works, okay, what it looks like, but maybe it might be hard to see this too. All right, because it's hard to tell if that's a maximum or a minimum, if it's curving up or down. And yeah, we can zoom in on our graph, but that might take longer than necessary. So it's much easier to plug in the values around it. Okay, so let's find the derivative when x is 1. Okay, let's also find the derivative when x is 3. Okay, so by just plugging those into up here, my derivative function, all right, we want to plug in 1 and -3. Okay, so when I plugged those values, 1 into my derivative equation, I got -200. When I plugged in 3, I got -240. So notice from this equation, I have a negative slope, a 0 slope, and then a negative slope. Okay, I can't have that. That's not a maximum or minimum. Okay, so by testing it, testing those values around it, I could really clearly see that that is not a max or minimum, so that's what's called your inflection point. So you've got at -1 is a maximum, 2 is an inflection point, horizontal point of inflection, and at 6, it's a local minimum. Okay? So if you're unsure if it's a max or minimum by your graph, you can always check the slopes around it. Okay, let's do another one. Find the minimum point on the graph for this equation. So I'm going to rewrite my function as y equals x to the -12 minus 2x to the -6. So when I do the derivative, I get -12x to the -13 plus 12x to the -7. Sorry, that was the derivative. Forgot to put the y prime. I wonder if you guys can hear that. That's my fridge, by the way. Sorry, that's like real annoying. Okay, it stopped. Anyway, so we have our derivative. Where am I going to go? Okay, we want to find the minimum point, so find when that equals 0. Okay, so let's see. Again, if we don't like that this has all the x's on the denominator, what we can do is we can get rid of them. Okay, so we can get rid of it all. I was trying to change my color. Okay, by multiplying by the denominator. So I'm going to multiply everything by x to the 13th, because that's the greatest common denominator. So we get 0 equals -12 plus, we'll think about what 12x to the 13th over x to the 7th. Those just eliminate. Sorry, equals -12 plus 12x to the 5th. So if I put it in order, I've got a polynomial equation. So I can use my polynomial solver. So when I type in my coefficients, make sure that the 5th term, x to the 5th is a 12, and all the ones in between are zeros, because we don't have x to the 4th, x cubed, x squared, or x. All those are zeros before you get to the constant. So then if I hit solve, let's see, we should get a whole lot of answers, because it's x to the 5th, which means we should get 5 answers, and we do. So if you scroll down, you're like, wow, this is really gross. If you go to the right, you can see that that's imaginary. I don't care about imaginary because I can't graph it. So that one's tossed out. This one is another imaginary, and you can see these are conjugates. So these are all imaginary. The only one that's good is x is 1, because I can graph 1 on my equation, or I'm sorry, my coordinate plane. I cannot graph an imaginary number. So x is 1 in this case, but we want to find the point, so we're going to plug it back in. So we get y equals 1 over 1 to the 12th minus 2 over 1 to the 6th. So basically 1 minus 2 gets us -1. So this point, all right, is 1 comma -1, which makes sense because that's where it is in the graph, right? If this graph was way over here, and I'd had that point, my 1 comma negative 1 would not make sense. If I got, you know, erasing too much. If my answer was negative 1 comma 1, we'd have a problem because that would graph right there. My graph is nowhere near that, okay? So sometimes the graph can help us just to make sure that we have the right answer. All right, so hopefully stationary points make sense now, maximums and minimums. If not, I'm in class.